Hello everyone, welcome to another Watch Me Do Math video. In today's video we're going to be looking at some problem-solving questions from the BMAT Section 1, 2016 and 2018. There are, as I can see it, there are 3 different types of questions that you find on these papers. 8 questions are data analysis and interpretation. Some questions are finding flaws in written argument or evaluating written argument. And the last type of question, which is what I'm going to be focusing on today, is questions which are similar to an IQ test. So they test critical thinking and mathematics skills in a pretty broad and non-specific way. So it's the kind of thing that you can't predict what the questions are going to be like, but there will be patterns in the past papers. I'm not going to comment on those patterns because I haven't done enough past papers to tell, but I will go through these problem-solving questions from the 2016 and 2018 paper and explain how I would do them, and if I see any shortcuts or fast ways that you could do them too. So let's begin. A school has 120 pupils in 5-year groups. The following table gives some details about the numbers of boys and girls in each year group. There is a probability of 1 in 12 that a boy is selected at random is in year 4. What is the probability that the year 4 pupil selected at random is a boy? Okay. 1 in 12 that a random is in year 4. So that means there are 12 in year 4. There are 16 boys. 8 plus 8 is 16. 6, 24, 8. 32, 16. There must be, these two must add up to 10. And if this is 72, that means these two must add up to, well, 18 plus 16 is 34. 34 plus 8 is 42. That means these two must add up to 30. And what I'm going to try and do is find the numbers of year 4 pupils that are boys or girls, right? So, this is 40. I don't know why I wrote 10 actually. This is 40 people, 80 people. Cancel with 24 is 104 people. So that means this must be 16 people in year 4 in total. There is a probability of 1 in 12 that a boy selected at random is in year 4. So that means there must be 6 boys in year 4. Therefore, there are 10 girls in year 4 if this total, 104 otherwise, brings us to a total of 16 year 4 pupils. Because if 6 of them are boys, as is suggested by this statement, then the other 10 of them must be girls. And so you have the probability 6 over 16, 6 year 4 boys over 16 year 4s, that a year 4 pupil selected at random is a boy, which would be 3 over 8. Okay, so my problem here was that I didn't read the question carefully enough. I should have, and realized that this was 16 rather than 10. I think it was just a bit of a silly mistake that I wrote 10 there. And I should have realized, like, the way in which you can think about this. It's unnecessary to calculate that these two add up to 10. It is only necessary to calculate that this value is 6 because of the probability of 1 in 12, i.e. 1 in 12 boys should be in year 4. And it is also necessary to calculate that there are 72 boys in total, given the fact there are 48 girls. Now you may notice that it's presented in quite a convenient table format, and I really like this because when I see problems like this where you're sorting a certain amount of individuals into different categories based on data given, one of my strategies to do these questions quickly is to draw out that kind of table. And they've drawn it for us already, which makes doing the math trivial. You just need to know what direction to take, and that was confronting each fact one at a time. So 120 pupils, that's the first fact. 1 in 12 boys are in year 4, that's the second fact, and then you are trying to find this thing. So anyway, our question mark would have been, what's this, what's this, what's this? Or not even what's this. You don't need to calculate this. You just need this value and this value. Here and here. Anyway, let's move on. Forced fires, conclusion drawn from the passage. This is argument evaluation. Charges for bed and breakfast at the Donclair Hotel are as follows. Guests who stay for 7 or more consecutive nights pay $40 for the whole of the stay. The bill for the hotel includes any charges incurred for the use of the car park. It's $5 per night or $25 for 7 nights. John stayed at the hotel recently for 5 consecutive nights, keeping his car in the car park. John never has any other charges added to the bill. He's booked 8 consecutive nights, and again will keep his car in the car park. Okay, so how much more than last time will John's bill for his next stays at the Donclair Hotel be? So you have 8 car parks versus 5 car park days, and 5 nights versus 8 nights. Because a car park has a 7-night permit for $25, and $5 will already be $25, you can cancel it out and get like 1 extra night worth of car park is the charge, right? And the second thing to consider is the amount that he pays for the additional nights. So if the first 2 nights are $50 and the third and subsequent nights are $40, that means you can cancel the first 5. He has 3 extra nights and then minus $20 because that's what he gets for staying longer than 7 nights. So these 3 extra nights cost him $120. This 1 extra car park night costs him $5. 120 and minus 20 cancel to $100, plus $5 is $105. So the thing to recognize here is that you can kind of cancel things out. Like we canceled the first 5 nights of car parking with the second 7 nights of car parking because we knew they were going to be the same cost. And that led us just to look at 1 night of car parking. At the same time, we canceled 5 initial nights with 5 of the other nights and subtracted $20 because we knew that the first 2 nights would drop to $40 given that he had stayed for more than 7 days in the second stay. And finally, calculating the last 3 nights, which is what we know are left over, is trivial. That's just 40 times 3. Then adding up the 3 amounts that we have to consider, 125 and minus 20, we get $105. Okay, let's continue. When we listen to music, flow on the above argument. Nope. Students in a physics class took a practical test and a written test. The results are shown in the following table. The table has a scatter graph shown below, but one student's marks are missing. Okay, it's not clear what the axes are, and I think you ought to assume that it's just practical mark plotted against written mark. So generally we know that there's some upward trend, right, with 1 outlier. And what I suspect is that if we can find any outlier which is way up in this direction, way up in this direction, an outlier here or an outlier here, then we'll be able to find sort of how the marks are. So, I don't know, I'm just looking at this for a moment. to me, intuitively, it seems like this is 625 because it's equally spaced from a 432 that's on here. Now I'm making the assumption that it starts at the origin, but the reason I say this is because 25 looks like it's smack in the middle between the second and the third horizontal lines, so that must be there too. So this 432 and 625 are here. So now we can just keep checking along. So this looks like it's 8, 9, 10. 8, 9, and 10 at a 40, 40, and like high 30s marks. So 8, 40, yes. 9, 40, yes. 10, 36, yes. And then this is 11, 12, 13, 14, 15, it seems like. So 11, 40, 50, 60. Yep. 12, 50. Yep. 13, more than 60, much higher than 60. 1368, yep. 1465, looks like. 1466. And 1554. And finally, you have one more at 19 on this axis, and I don't know, 10, 20, 30, 40, 50, 55. It's this one. So the one that's not here is the only one remaining, which is Kahn's mark. Now the key here was that I recognized that this graph had this certain, like the size of the increment seemed pretty regular, and at the same time, it seemed to me like just looking at the lowest 2 points, I thought I could identify what those points were, and I thought, if I can identify what those points are, then I'll probably be able to identify the scaling on the axes, because it's not going to be like logarithmic or anything. It seems like this is what the scale is, because if this was 6 and this was 4, I thought the thing in the middle must be 5, so it's probably going up in steps of 5. And then I realized, okay, these two are the lowest two, and they follow the pattern of the lowest two, right? So that's how I initially knew the values of this. And then I realized, if this is 25, and it's halfway between the second and the third, then most likely this is going to be 10 per horizontal line, right? And then after this, I noticed that the 32 is slightly above where I predicted it would be 30. So my theory that each horizontal line was 10 points apart was correct. So going on that pattern, I found that additional points also corresponded to this pattern, and I just continued to work through all the points, crossing them off until I found the last one. Alright, let's continue. Main conclusion of the above argument, this is critical thinking. Citizens of BMAT pay tax on their incomes each calendar year as follows. In 2014, Paul paid a total of $5,600 of tax on his year's income. Okay, tax-free, so $0 paid. 20% of the next $25,000 means $5,000 in tax, and so 600 must have been the 30% of his further income. So that means there must have been $2,000 of further income. So $9,000 plus $25,000 plus $2,000 makes well, this is with the assumption that he's under 50. 9,000, 2,000, 11,000 plus 25,000 is $36,000. And if he earned $38,000, logically, if he had stayed under 50, then he would obviously have to pay more. But it seems like he's paying less because he has become a higher earner. He's earned more. Like, it's because even though he has earned more money, he's paying less tax. So this 14,000 is free. I think we can immediately say that it's going to be $38,000 because calculating his income from his first tax and then calculating that he's paid less tax despite earning more, which is what you would logically expect of a tax system to be like kind to seniors or something like that. So 38 goes down to 26 of taxable income, and this bracket is 19, so 19,000 at 20%. 20% is around $4,000, and then $7,000 at 30% is going to be around $2,000-ish. I don't know, like, oh, I see the mistake. I just subtracted incorrectly. 24 at 20% is going to be around $5,000, and 30% of this is going to be $1,500. That's interesting, actually. I'm gonna pull out a calculator and check whether this is a correct calculation. I suspect it is, but I'm not entirely sure. So 5,000 times 0.3 plus 19,000 times 0.2 is $5,300. That is really strange. That is pretty curious. Oh, I realize why. I realize what's happened. I've made a calculation error. The first 9,000 is free. The next 25, it's the next 33,000 is at 20%. So all of the rest of it, not just up to 33,000, it's more like it's up to 47,000, is at only taxed 20%. So this answer is correct. I just misinterpreted the second column. So the answer is $38,000, and we were able to calculate this by firstly noting that he paid less for more money, meaning that he must have changed tax systems entirely. He's gone from under 50 to being 50 and over, and then calculating his original income from the first tax statement. I don't think you need to do any other calculations once you've calculated that fact, because the rest of the problem is just a bit redundant. It just serves to confirm what you already know about his income. So in essence, you only need to note the fact that is presented here and then calculate his original income based on this column. This is data analysis. I'm going to skip it. Time is represented in an unusual way in Bolandia. The format is minutes hours, where minutes represents the number of minutes the next hour. Okay, so she's staying in a hotel. The clocks in the hotel display time this way. When she goes to bed one evening, the clock in her room reads 21:23. So 21 minutes to 23:00 is 22:39. And 23 minutes to 4 a.m. is 3:37. Wow, she didn't get much sleep at all. So if this is 1 hour and 21 minutes of sleep to midnight, followed by 3 hours and 37 minutes of sleep, it adds up to get 4 hours and 58 minutes of sleep. So the key here is just to be confident about thinking in this new system that is presented to you. you should immediately, like, once you see the instruction as to how the new system works, you should immediately be able to think about it in that sense. 21:23, like, read it out in your head as 21 minutes to 23. And 23:04, read it out in your head as 23 minutes to 04, and something like that. 21 minutes to 11 p.m., 23 minutes to 4 a.m., etc. Okay, now let's move on. This is critical thinking. This is the argument one. At the beginning of last year, Sam had $1,000 in her bank account. The following graph shows the changes in hundreds of dollars in the balance of money in her account over that year. At the end of how many months did Sam have more than, strictly more than, so 1,400 or more in her account? Well, let's think about it in terms of just hundreds of dollars. So you start with 10, we add 3, 13, subtract 2, 11, add 2, 13, do nothing, 13. Add 4, 17, subtract 2, 15, so that's 1 month, 2 months, subtract 4, it's 11, add 2, 13, subtract 1, 12, add 3, 15, 3 months, subtract 1, 14. 4 months. So overall there are 4 months where she had more than 1,300 in her account at the end of the month. The trick here was that you only needed to think about the account in the hundreds. There was no point in writing out 00 because all of these values are clearly like, all of these values are only to 2 significant figures basically. They're only to the 100ths place, and no money changes occur with more precision than that. So you could just write down what happens to the account in each month and circle the ones that meet the criteria in order to, at the end, easily visually count up what the total number of months that met the criteria was. So let's continue. That's a argument evaluation. 5 friends are sitting at a round table playing the LRC dice game. Oh, the LRC is I don't know, it's just like a private club in Hong Kong, so that's quite funny. There are 5 dice. Each face of each die has one letter, L, R, or C written on it. Going clockwise around the table, the friends are seated in the following order. A, C, I, P, R. Each friend has 5 coins for the game. Each player in turn rolls the 5 dice and distributes their coins according to the letters on the top dice. An L on the die requires passing 1 coin to the one on their left. An R requires passing 1 to the one on their right, and a C requires putting 1 coin in the center of the table. They're going clockwise. It's this A, C, I, P, R. So to go to the right, to their right. So to A's right is R. To the right, 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 and then to the left, to the left, to the left, to the left, to the left. At the end of the round, which player ends up with the fewest coins? Each friend has 5 coins. Okay, so the first thing you can consider is that if each one passes 1 to their left and each one passes 1 to their right, then overall the net effect is that the game has not changed in any capacity. So you can cancel out all of the left motions and cancel out all of the right motions by 1. So just look at these and these as well as the passing coins to the center. At the same time, you can cancel out all of these and just say that he starts with 4 coins and the rest start with 3 coins. So then we consider each of the actions in turn. To their left, Alan passes 1, so this becomes 3, 4. To the left, Carmen passes 1, so this becomes 3, 4. And to the right, Prem passes, to the left, Prem passes 1, so this becomes 2, 4. And then we consider what happens with the coins passed to the right, so this becomes 2, 5. And then Ian passes 1 to the right, so go up, 3, 4. And Ruthie passes 1 to the right, so this is 4, 3. So our final numbers are 2, 4, 3, 3, 4. Which player ends up with the fewest coins? It's Alan. So the key idea to notice here was that the center was very easy to evaluate, and you could just evaluate it by putting everything in the center. The second thing to notice was that if everyone passes 1 coin to the person on their left, then nothing changes. And if everyone passes 1 coin to the person on their right, then nothing changes. So you only need to account for the sort of extra bits. And the second thing I want to point out is that I suppose you could go a step further and suppose that every person has passed 1 to their... Actually, no, that's probably too tedious. But I was trying to think of more ways that you could simplify this problem. But I think the cancellation of 1 whole loop is already very useful, as well as the fact that you can account for the center coins the easiest. So A ends up with the fewest coins. This is argument evaluation. I have a deposit of $25,000 pounds that I want to use to help to buy a house. The purchase price of the house is $150K, and the remainder of the cost of the house is to be financed using a mortgage. My building society offers 5 mortgages, the details of which are published on its website as follows. The bank base rate stays the same with the next year, so this is 3% and this is 4%. Which of the mortgages that I am eligible for will cost me the least in fees and interest over the first year? The purchase price is $150. So basically, this guy can afford to put down 25K for a house, and I think he can't actually. I don't know. I think he can't actually take mortgage 1 because he doesn't have enough to put a down payment. So the first mortgage is not enough because the loan-to-value ratio is 75%, and the next one is not enough because the loan-to-value ratio is 80%. So let's think about this. The interest rate is 5% fixed, meaning that let's see how much money he actually gets. Here he will get 135K, and 142.5k. At 4%, he will... 1 single percent of each of these is roughly 1,400. So at 5%, he'll get about 7k of fees. Here he'll get about 4.2k of fees, and here he'll get about 5.6k of fees, which goes to 6.6. This one goes to 6.2. Remember, we've underestimated this one, we've overestimated this one, so this is certainly more. And then this one, 7k plus 1,500. It seems like the fourth mortgage will be the best, but I'm not entirely sure because this question is a bit funky. It's like, I don't know, I don't have much experience working with these kinds of quantities, and it seems like to me number 4 is the best because the amount loaned as well as the fee is such that like the interest plus fees are the least. I don't know, this is just like a bit of a headache, this question. I think I'm pretty sure the first 2 mortgages are invalid just because they simply don't cover the cost of the house, right? Yeah. Okay, so this is a data analysis question. I don't know. I think I'm certainly not gonna do the 2018 paper in the same video because that would be a bit insane. I think this video is gonna get pretty long already. I'm gonna cut it off after this paper. The drawing below shows the outlines of 3 pieces of card which all fit exactly around the same size circle. Oh, okay, so I looked at this question before and I thought, surely there must be some obvious way to do this faster, and the key was, you need to notice that every line touching the circle is a tangent to the circle. It cannot go into the circle in any capacity or it's invalid, and at any point on the circle there is only one line that can touch the circle without going inside the tangent line. So if you have any scenario where there's the circle and a joint here and a joint here, it is impossible that this angle would be anything other than 180 degrees, otherwise you have 2 lines, and even if one of them is the proper tangent line, the other line is definitely going to intersect the circle somehow. And that is a big no-no, as you can see, because these shapes do not, like, they don't, what's the word? They don't have any scenario. They don't have any lines touching the circle which are not tangents. So A is immediately gone because we have this joint here, and that's illegal. B is okay. B is possible, but I'm just going to explain why the rest of it won't work, because this one won't work. You have it cutting into the circle. D won't work because you have it cutting into the circle, even though that is a tangent line. And E won't work because you have it cutting into the circle too. So even though it doesn't look like on the drawing this is a straight line, mathematically speaking, it's impossible to have a joint like this where both lines do not cut into the circle and invalidate the shape. So B is the only possible outline. Now let's move on. This is argument evaluation. To mark Back to the Future Day on October 21st, 2015, the Galaxy Cinema screened all 3 of these films in order twice. The running times were as follows. Okay, performance times arranged that the first showing began at 10:15 and the second showing of the last film ended at so from start to end it was 10:15 to 22:45. So 10 to 23 is 13 hours minus 15 minutes at each end, so minus 0.5, 12.5 hours, times 60, this is equal to 25 times 30, or 50 times 15, or 750 minutes of time in total. And the interval between successive films was the same throughout the day. There would have been 5 intervals because you have movie 1, movie 2, movie 3, and this starts at 10:15, followed by another movie 1, movie 2, movie 3, ending here. And you can see that there are 5 gaps in between these 6 blocks of content. So in total, these films sum to 16, 25, 2, 4, 3, 345 minutes of film content. 345 times 2 is 690 minutes. And so subtracting 690 minutes of film time from 750, well, there's a fire engine outside my apartment building, you get 60 minutes of breaks in between the films, divided equally between 5 breaks, getting you to a value of 12 minutes. Okay, the video's at 36 minutes now. I'm certainly not going to do the 2018 paper. The sale of self-help books, flaw in argument. The table below shows a record of my blood pressure and pulse readings over 9 days. What was my pulse on the occasion when I had the biggest difference between systolic and diastolic readings? Oh, that's a disgusting and evil question, because you need to visually see like the difference between these. So what I think is you should think of the diastolic as a certain number, 100 minus x. Like, if you see 98, you should immediately say in your mind 2. If you see 94, you should immediately say in your mind 6, and so on. At the same time, you ignore the 1 in front of all of these numbers. You're only looking at the tens and units digit, because you're going to add that to the distance of the diastolic from 100. So if you have the diastolic and the systolic and the point 100 here, when you see the diastolic 98, you're going to be like, oh, this part's 2. When you see the systolic, you're going to be like, oh, this part's 35. And that's the systematic way in which you can find the difference between the systolic and diastolic blood pressures as easily as possible. So 35, 98, you get 37, 38, 6, 38 plus 6, 44, 39, 3, 42, 49, 4, 53, 49, 4, 53, 46, 4, we know immediately that's not. It's going to be 50, 33, 7, 40, 28, 16, 44, 49, 19, 68. Okay, 68 is pretty massive, and we can start eliminating things based on, so we know it's here for now. We can start ignoring things that are obviously less than 60, like 49, 3, obviously less than 60, 46, 3, obviously less than 60, 34, 9, obviously less than 60, 65, 1, 66, doesn't quite get there, 41, 14, 55, 39, 9, 48. Oh, my pen stopped working. You gotta be joking. No, let's see if this pen decides to work later. But 41 and 14, 55, 39, 9, 48. Oh, it must be a problem with this, because my mouse is not working either. Ah, thank God. Okay, 55, 48, 26, 12, much less than 60, 45, 22. 67, 67, just not enough. 63, 4, 67 as well, and 29, 90, obviously less than 60. So we're looking at this 68 difference, and the pulse is 86. Okay, so lessons learned. While the most obvious way was to try and calculate the difference between the S and D at every level, I realized it was apparent that you could visually see whether something was obviously bigger than a certain difference. Because if something was, like, at first glance, having a difference of 30 when your maximum was 68, you could just safely ignore it. And that's how we sped up our process of looking at the other values in the table. Okay, let's continue. Argument evaluation. I have a piece of string which I stretch out in a straight line. I then take a thin red felt tip pen and make a small mark in the middle of the string. Then I fold the string in half again and stretch it out, holding onto the fold and to the two ends. This time I make a small mark in the middle of both strands of the folded string with a thin green pen. A thin green pen. Oops. Okay, I don't know how to undo that. Right, thin green pen. Then I fold it in half again and make a small blue mark in the middle of each strand of the folded string. And then I unfold the string and stretch it back out to its full length. How many marks are there on the string in between the two green marks? Okay, so if you have one string and there's red in the middle, there's green mark 1 here, green mark 2 here, and overall the thing is divided into 16 pieces because of the way you folded it, then you're going to have the blue here, and also the purple here, 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 and here. And basically, it stems from the fact that you know that each part of the string was divided by half by each mark. So, you know it's all of these in between the two green marks, which are at the 1/4 and 3/4 point. So in total, 7 marks. This is argument evaluation. There are 2 types of gold that can be scored in the sport of charge ball. A fess worth 7 points and a pail worth 2 points. Okay, so there are fesses and sables. The agent scored 1 fess fewer than the sables. The sables scored the same number of fesses and pails. Okay, I can't see this symbolically. And the argents scored exactly twice as many pails as fesses. I think, yeah, I can't see any obvious way to do this non-symbolically. Like, I can't see any particular diagram that would help. So the sable scored some number of the total goals, like 9x is their total score, is agents scored 1 fess fewer than the sables. So 7x minus 1, if x is the number of fesses the sables scored, and the argent scored exactly twice as many pails as fesses. So the Sable's score here is +1 is equal to the Argent's score. And you can do everything quite easily in terms of the number of fesses and pails that the Sable scored. So if 9x plus 1 is 7x minus 7 plus 4x minus 4 minus 11x. If we add 11 to both sides, this becomes 12, and removing 9x from both sides, this becomes 2, so x is 6. That means if x goals of each type were scored by these guys, 2x minus 2 is 10 pails scored by the Argents. Now notice how, again, I did not write the working for these equations down completely, nor did I bother with making like equations for other variables. I didn't put like x, y, and z, and y is something x and z is something x. No, though that part is obvious enough in my opinion that if you are comfortable with it, you can write down the expressions in terms of x right next to the number already without any other working. And in doing that, you save a lot of time when it comes to doing the actual algebra as I do here. And my tips for doing this algebra quickly, that is involving things like skip steps that are obvious and write as much as you can on one line before writing out another line, that still applies here. So finally, questions 32 to 35, this is data analysis. And I think that is it. That is it. So we have done the 2016 paper. I'm going perhaps to do the 2018 paper another time then, because this takes so damn long. And until next time, if this video has helped you, please be sure to subscribe, and thank you for watching.